Hello, everyone. So I'm gonna speak about decentralized science. Maybe just for a show of hands, who has heard of decentralized science or knows what it is? Okay, so maybe half. Yeah, so decentralized science, DeSci for short, kind of means kind of the intersection of crypto and science. And I'm gonna speak about kind of the purpose and impact of decentralized science, kind of the high-level ideas, but also where it stands today. Yeah, and for context, I've helped create VitaDAO, which maybe some know, and running an ecosystem at Molecule. So I'll start in the first part on why DeSci and what does DeSci look like in practice, how does it work, and kind of hopes for the future, what the ultimate goal is for DeSci, because it's quite a young movement that I think really only took shape in the last 2 years. Perfect. So maybe as a starting point, kind of it's a presumption that kind of science is the ultimate engine of human progress. Like I think we wouldn't have crypto, we wouldn't have modern cities, or anything for that matter, I think, without science. So I think this chart is illustrating this well, kind of like the scientific revolution and scientific progress kind of kicked us off into the modern age. And I think we can reach the flying cars and everything as well with science. So I think it's quite important and something that also Ethereum should enable and plug in with. So kind of there's of course like the scientific method, which is at the core of how we do science, and I think also relates even to things like protocol development and other things, starting with observation and question and really resolving this with a scientific method, like testing hypotheses with experiments and analyzing those and drawing conclusions. The problem is, of course, that science as like we know it today is pretty broken and has like a lot of problems that I think Ethereum can help with, and crypto more broadly. So one of the main problems goes in the direction of funding, which is insanely centralized and mainly around government bodies like the US and EU, with like bodies like the NIH, which predominantly, for example, the NIH funds mainly old people. Like the amount of funding going to under 35-year-olds is less than 2%. So it's quite like bureaucratic and slow-moving institution, and a lot of those centralized funding bodies take months, sometimes many years to get back to you, to your application, and then usually don't fund you, especially not for moonshot, really impactful ideas. So there's a lot of problem around funding, and I think that's something where actually also our focus is, and I think that is one of the most obvious ones with crypto, which of course with programmable money and all the primitives, I think can really power science funding, and I think there's been already a lot of progress in this direction. Then another one is the replication of science. So a lot, actually, the majority of papers doesn't replicate, and there's many, what it means is you can't reproduce the same results. And there's multiple reasons for this. One is that often actually the data goes missing, and people just don't have the context to do it again. So potentially permanent storage, for example, could help with this. But also a bunch of other problems, like that it's not well documented. Sometimes it's even completely faked. So there's no really ways to check that some of the science that our society is building on is pretty flawed and wouldn't replicate. Then there's the problem of hyper competition, which results in very incremental, hyper-competitive environments that I think are not really conducive to more longer-term ambitious science. So it like results in a lot of short-termism and people publishing a lot just to get like professor positions or to get the necessary funding. And then ultimately, I think one of the biggest problems is around the communications. So it's largely inaccessible, and it's crazy if you think about it that all of you fund science through your tax dollars, but none of you can access any of that science. Like you can't read it without paying $50 to read a PDF. And like you can, it quickly adds up. If you want to actually understand what's going on, you pretty quickly spend a lot of money just to pay for the science that you actually paid for as a taxpayer. And I think that's also a large problem. And ultimately, even the scientists actually like also have to pay to publish in journals that then are paywalled. So there's a huge problem there, and I think also something where decentralization and can really help. So let's jump in on kind of some of those problems stem from centralizing authorities. Like as I also mentioned before, like especially around the funding, it's quite a small amount of funding bodies that does the majority of the scientific funding, and they kind of favor also a specific kind of funding. Like you can imagine that like the NIH is not funding more wild research, which some of the people in crypto actually are some of the biggest funders. And one fun example, for example, is cryopreservation, which actually one of the core inventors of Bitcoin, Hal Finney, funded. A lot of people like Ralph Merkel and others are deep in it. And actually already like that field is predominantly funded by crypto wealth and like zero government funding. It even helps for stuff like organ preservation. But then there's also on replication, there's new experiments in DeSci that kind of help to resolve this, mainly by making the data permanently available, having clear protocols so people can actually just run the experiment virtually again. So there's a bunch of projects in this direction, like LabDAO, for example. And I think on the competition part, for example, we have created VitaDAO, and there's now a bunch of other scientific DAOs that really enable more collaborative, positive sum environment for scientists to collaborate and have an incentive to collaborate. So what if science is decentralized? So I'll just quickly go into the why, what, and how, and kind of like on the why, the reason and kind of like how DeSci I think is shaping up is that it's really building on the open science movement to make science much more collaborative and actually accessible to everyone. It's kind of crazy if you think about it that it's such an important process, but only like 0.1% or something like this of the world are involved in science. Like most people are neither funding it directly nor able to actually engage in science or advance science. So the goal is really to democratize science, similar like how NFTs maybe have democratized the creator economy, that everyone can get involved in science or even get funding to run their own scientific experiments without having Harvard PhD or something, because I think there's a lot of untapped talent and opportunity for people to contribute to science with their software skills, with their communication skills and other aspects. And then on the what, kind of the idea is to create a global open alternative to the current scientific system, where like everyone can participate in, and of course through kind of the different Web3 technologies to raise funding, to actually run experiments natively through Web3, and to share data, distribute insights in a much more open way. So why is it important? Why is decentralization important? I think the interesting thing is there's a lot of values that Ethereum and crypto share that I think are quite important for science, mainly around, of course, open source culture, transparency, and broadly decentralization. So I think those are also quite important for science. And of course, also by design, crypto is internet native and enables global access for everyone to participate. It's trustless and permissionless. So I think that's also quite an important value for science. And then censorship resistance, like ultimately it's less common, of course, maybe in Europe, but like a lot of science, for example, around COVID, got censored in different places of the world. So I think that's also something where permanent storage can help to make it censorship resistant. And then enabling permanent storage, because it's crazy that like a big chunk of the science that we're building on is literally like forgotten. It's like lost on hard drives. It's lost because people died, or like because it was stored on their server and then that server got taken down or something. So I think it's quite important to just for humanity to preserve its whole scientific corpus. That's kind of like a more like a comparison between tradSci and DeSci on the different dimensions, which is also on the Ethereum website. If you go on ethereum.org/DeSci, it just basically compares what I also already mentioned on how funding is broken in tradSci on being focused on a small, closed, very intransparent, centralized group that is allocating the funding, while in DeSci it's literally happening in the open. Literally, for example, in VitaDAO, it's in a discourse governance forum, like other governance proposals being discussed by different scientists, weighting the different pros and cons of specific research projects and discussing it in the open, which I think is also quite important for people to communicate and to understand science, almost more like an apprenticeship model where people can just learn by reading the evaluation from other scientists. And then, of course, on collaboration, which I also already touched on, also DeSci, I think, can be by nature much more collaborative, especially through DAOs. On labs and infrastructure, for example, LabDAO's a project we supported that is building kind of like an Airbnb for labs and for also wet lab compute. So basically that you can run experiments from your laptop in the browser and access from compute to kind of like cloud labs. So the goal is really to at some point make science as easy as building an Ethereum app or like an app in general, that you can just run it from your laptop and don't have to have access to expensive laboratories that are usually not around in most countries or cities. And then on publishing, there's also now a lot of experiments. One is, for example, from the Coinbase founder called Research Hub. And there's also DeSci Labs, which is building a new decentralized publishing platform. And actually, VitaDAO just launched its own decentralized journal called Longevist, which goes also in peer review. So basically, the idea is instead of having peer review happen behind closed doors, where like your competing peers review you with like no incentive, no compensation, and no incentive really to review you in a honest way, because then they don't get funding at the end. So the goal is to move peer review completely to the open and basically compensate also people for peer reviewing. So for example, VitaDAO is doing an open longevity journal, and every scientist is openly reviewing it and gets compensated for it. And then, for example, on intellectual property, which is the main asset class of science, in traditional science, scientists get zero ownership in the science. It's usually the universities who get it, and then they have to negotiate with the universities to out-license their own intellectual property and have often to pay a lot of money if the research was successful. And in DeSci, what we actually do is we go to the universities and give funding to a researcher before kind of they take on the research and get an exclusive license. So ultimately the DAO and the researcher actually has ownership in the IP, while in the old model it was mainly the university, which then is also incredibly slow to move for licensing and other things. So it's often these science gets stuck in universities and then just dies down, doesn't get translated. And then of course also on the incentive layer, on like DeSci can re-engineer the incentive around also sharing all kinds of data, including negative data, by just doing all of these steps in the open. So I've already touched a bit on it, but like on kind of what does DeSci look like in practice. There's different verticals. One I touched on is the funding and IP layer, which I think is one of the most thriving layers where we are most active. So there now has been dozens of research projects funded in the first 1 or 2 years of DeSci's existence, and it really enables just much faster funding and also more democratic. And like the scientists can really see like how people evaluated his project, how many people voted in favor for funding it. So it's much more transparent, and I think a much better experience overall for the scientists, who then also are valued and like appreciated by the community, and and also engage with the community. And then also there's like a huge vertical around publishing of science with a lot of projects and about reproducibility and identity and reputation. But I'll touch more on funding and IP. So science funding is in DeSci is making strong progress with a lot of the BioDAOs we've helped create. VitaDAO is the main example. But there's also other experiments going on that we supported, for example, on retroactive public goods funding and quadratic funding more broadly. So together with Gitcoin and Vitalik, we did a quadratic donation round for longevity that raised over $1 million, and one for decentralized science more broadly, which also got over $1 million together. So there's already the first kind of thriving of public goods funding as well, of open science that is funded through donations. Then, of course, there's these DAOs that I touched on with tokenized incentive structures. So a lot of BioDAOs, kind of after VitaDAO came now like a lot of bio and science DAOs for different therapeutic areas. For example, like AthenaDAO for women's health, UpsideDAO, and a bunch of other DAOs that we also fund and support through a program called BioXYZ. And then there's this whole new asset class of IP NFTs and IP tokens that we created, where I'll go into some of the detail how it works. So our focus with Molecule is on making IP transactable in crypto and enabling sustainable funding loops for scientific DAOs. And the biggest challenges in intellectual property in patents are that they're monopolistic and create perverse incentives. They're very analog and don't have a basically a digital footprint, and they're not programmatic and very intransparent. It's very hard to get an overview of like the IP out there, and it's very hard to buy it, to license it. It's usually done in the physical world. You go to a university, try to understand what IP they have, and try to license it from them in email chains, basically. And it's very liquid, so it's hard to transact and transfer, and impossible to use as an incentive. And it's not standardized or global. So our idea is a bit like Y Combinator did a SAFE agreement for startups. We want to create standardized IP agreements. Yes, so I'll touch on this, that with Molecule we basically build like a science marketplace and protocol for like kind of like the OpenSea for science funding, and the IP NFT protocol to bridge basically science into the digital world. And kind of the ecosystem now raised like over 35 million from like including the science DAOs to start funding a bunch of science. Yes, so the goals with IP NFT is to improve and upgrade the intellectual property system, which I think needs a lot of improvements and is pretty broken as it stands today. But ultimately, we're trying to build a solution on top of making digital IP transactions possible, creating liquid markets around IP, and enabling fractionalization of IP, so people can, there's price discovery around IP, but people can also, as a scientist, get incentivized in the native asset class. Yes, so it's basically composed of different components, like a legal component, which is stored on chain, but then also it's natively transactable and programmable, so it can be used in governance, can be used to be fractionalized, can have programmatic royalties, and even more public goods funding like models like pay for success models. So basically the legal contract is referenced on chain through like an Ethereum smart contract, which contains like a metadata JSON with like the different information about the research project, and then also an encrypted data room with kind of all the scientific data and IP attached to it. So it kind of also serves as an access token to all the data surrounding the research project. And recently we also fractionalized the first IP NFT into an IP token. So basically that people can now buy fractions of an IP NFT through IP tokens. So you can see it on vitadao.com, kind of like how it works, but also the research project. And I'm quite excited for this, so people can directly crowdfund a research project together. So that's kind of like the ecosystem right now. So it kind of really exploded into many different DAOs, many different publishing efforts, and it's even more than that. So it's like hard to keep up with. And like it's a similar moment that I realized in that Ethereum happened in 2017 or 18, when there were so many things being built that at some point it became impossible to keep track. I think that's now also happening with DeSci, where there's like many more projects than one can keep up with in all kinds of different therapeutic and scientific areas, and also around publishing, funding, data storage, and other aspects of science. And for VitaDAO, we now funded over 17 projects with over 5 million, some of which are now quite progressing rapidly, and looked at over 400 projects with like 9,000 members, and like have an additional 6 million in cash to fund science. And what was for me one of the craziest moments was last year Pfizer got on board and is now actively voting in DAOs and writing in governance proposals, which was unexpected 1 year in. And that's kind of like, I'll quickly skip because my time is running out, but that's kind of like the flow of how the funding works. So basically scientist applies, the community evaluates the proposal, like scientists, MDs, and experienced people in the field. Then they write up a governance proposal with their evaluation. Then the community actually asks questions and the scientist answers them. And then at the end, it's put up for an on-chain vote. And then if it's funded, then it's advanced and kind of like further managed towards hitting its milestones, and then making further decisions if it's been out into biotech, sold or licensed, or if the DAO uses additional funding to advance the project further. So those are some of the projects, and on the website we have all 17 projects we funded. A bunch of them also things around more public goods funding, like we funded 60 students entering the field, like from Kazakhstan, Turkey, to like all other places around the world, in different parts of the world, to support them in their entry into the field. But also things like a decentralized science prize and other things that got funded through the Gitcoin round. So I'll end on some of the goals for DeSci and the hopes for the future. One is like to enable every human to be a scientist and participate in science. And I think, of course, one of the prerequisites is that one has something to participate. I think that's where, like, I think the crypto community can, on the one side, educate themselves. Of course, there's a lot of skills from software engineering to others that can be quite useful, and also has capital to fund science. And I think the true power is really that it's now, like, through IP NFTs and other things like BioDAO tokens, more like an asset class instead of a donation. So people don't just need altruistic reasons to fund science. And then the goals also for patient and researcher communities to govern the cures and access to medications. So for example, imagine like a community of diabetics managing and collecting funding to advance diabetic medicines like insulin. I think it would be like more fairly governed if patients themselves would have a voice in how it's developed and priced and governed. And then one of the goals, which right now is insanely broken, is that most of the leading scientists spend over 50% of their time applying for funding. And our goal is to reduce this ideally to less than 20%, so that they can actually start focusing on science again, and also on doing bigger, more moonshot projects, where I think also crypto and a lot of the bigger crypto funders have now funded a lot of inspiring moonshots. So I'm not sure if everyone is aware of like all of those projects, but everyone from Vitalik to the Coinbase founder to Juan Benet have kind of basically stepped up to become some of the biggest science funders in the world, like with like between 10 to like $1 billion, which puts them literally at nation states. Like I think Vitalik funded more science than the 20th biggest nation states. So he's like literally funding more science than New Zealand like last year. Or than Saudi Arabia, which is pretty crazy to think about. And then the goal is also to share knowledge, data, and resources much more openly, to have negative data be openly published and communicated, and making science as easy as logging into a website or participating in crypto, enabling scientists to be fairly compensated and paid, where I think also crypto native incentives can really help, similar as NFTs helped creators. Then to really decouple science to an extent from the tradSci institutions, that people can become independent researchers and do the most ambitious science. So, like to summarize, the goals to use crypto mechanisms such as DAOs to help distribute funding more equally, to increase transparency, enable collaborative peer review, and make research much more openly accessible, and improving science communication broadly, ultimately improving the objectivity, rigor, and reproducibility of scientific research. So call to action, join a community, apply to get funding, fund a DAO or research project, or get compensated for just sharing a link to a friend that is looking for funding. Thank you, everyone, and you can check the link for kind of like a link tree of all the articles and projects if you want to get involved. Like I would recommend as a starting point ethereum.org/DeSci explainer, which I think has the best overview and also a lot of links.
Thank you. I think we can have a small Q&A session while we set up the next speaker. Does anyone have a question?
Thanks, Vincent. Really appreciate it. From Australia, and big fan of yours and the work you're doing. So good fun here. This is just a bit of a fun question. You mentioned Pfizer coming on board for Vita DAO. I think like actually it's awesome to see like traditional pharma come on board, but also it's kind of like the equivalent of a big bank coming on to DeFi. So what are there any like problems you foresee perhaps in like research being funneled in a particular way for their interest, maybe, or what's? I would love to hear your thoughts on that.
Yeah, great question. And like I had similar concerns a while ago, but then realized that ultimately a lot of the pharma and biotech players are still the ones that bring all the drugs to market. Like if we look at the landscape today, they are more like private equity. Like they use $500 million to carry like a cancer drug to market. And I think the one decision was a governance vote to the community where they actually got quite a small stake. So I think Vita was like worth 80 million or something, and they have maybe 1 million of that. So like almost like 1% of the vote. So I think that was quite important that they are not too big of a voice. And I think the other is that they're actually mainly interested to like enter the field of longevity, which I think is also quite like it was literally their first involvement in the field of longevity through this. And I think ultimately kind of DeSci needs big biotechs and farmers to carry those things to market, because the amount of capital required is pretty staggering. So the average drug takes like roughly $500 million to bring to market, which of course I think for now DeSci is not well equipped to do this like hundreds of times. But I think at some point it might. And I think there's of course different incentives that play out at this large scale. And I think they're fairly broken, but ultimately I think pharma and biotech is operating under broken scientific incentives that I think we can fix. So I think at the end of the day, there's more complex incentives that are broken at the end of the day around even health insurers and others, which was an area I worked on like many years ago. So I think it's a bigger problem in general that like incentives are broken for translational science, especially in late stages. But it's still an effective translation engine. But it's ultimately cures are not as profitable as things you can sell for a long time. So if you cure a disease, then your market is
I have to interrupt
sold. Yeah.
Okay, thank you, Vincent. Sorry for interrupting because we need to proceed with the next speaker. Thank you.